away. So this workshop is a little bit modified because, as not being part of the bigger workshop, I thought I'd go into a little bit more of the history of NFC, because the first thing people say is, well, what's NFC? And the answer is it's near-field communications, which doesn't answer anything. But it helps to understand what near-field communications means if you understand the context of it, which is that NFC is part of RFID. It's a form of passive RFID. And RFID's been around arguably a really long time, but at least since '84. And it became pretty popular in the '90s when Walmart and Target started doing pilots on forcing suppliers to put RFID tags on the shipments that came into the distribution facility. And the beauty of it for them is that everything that came in on these pallets had to be tagged with an RFID tag, or at least at the pallet level, if not at the case level. So whatever granularity made sense to know what was on the pallet. And the beauty for them was that the forklift comes up, they grab the pallet, and they drive by a gate, and the gate reads all the NFC or RFID tags on the pallet. They don't even have to slow down. They just go drop it off. There's no receiving. Nobody's doing any inventory. And that worked out really well for them. I'm not sure their suppliers liked it as much, but it wasn't really their choice. And there's a tremendous savings to them because, as I say, they don't have to do anything receiving. Just grab the pallets, put it back, put them, take them out into the warehouse. And they would audit them occasionally, and you would get in a lot of trouble if you failed any of the audits. If you failed 3 audits, you were kicked out for a year. If you failed 5, I think you were kicked out for 3 years or whatever. So they take it very seriously. But basically, it saved them a lot of money. And so by the late 90s and early 2000s, companies like Walmart and Target were forcing their suppliers to there was compliance. Everything had to be RFID. But RFID is a little different technology. It's designed to be able to read a large number of tags from a significant distance. So 10, 20, 30 feet away, read them at 70 miles an hour, going by, you can read lots of them at a time. So it's great for that kind of an application if you envision that forklift going by.
So is each individual item tagged with RFID tags?
No, it doesn't, in their case, no. Typically it's case level, especially if you have a mixed product pallet. If it was a single product pallet, you could just mark it at the pallet level. But basically, it was enough for them to know where to put it in their distribution facility.
What's long read range? What is the read range of RFID?
I've got a slide coming up to show you that, but RFID can be up to 30 feet. Actually, it can be longer than that if it's active RFID. There's 2 types, active and passive. Active RFID has power and can generate a signal. Passive RFID is basically a chip with an antenna that receives a signal from the reader and generates enough power from that magnetic induction to be able to generate enough power to fire up the chip and send back the signal. So they don't require any power.
I believe actually with the right antenna you can get up to a mile. But it requires a specific antenna. That's with passive.
Is it?
Well, I've got a slide that I'll show you kind of from a frequency standpoint. So the industry that was the most successful with RFID is really the clothing industry. So retail clothing. Pretty much, everybody in retail understands the value of knowing what you have on hand. And you know that if you go in for a size 31, 30 jeans and they don't have it, you're not going to buy something else. You're going to leave, right? So they have to have the right size. So they want to know what's sold, what's on the shelf, what I need to put back on the shelf. So it's been really successful in that vein. And so I'm going to just run this little video here. And what I want you to listen for is, hopefully you can hear it, but the read rate of this device as it reads the tags in this retail outlet. So there we go. Just had to ask.
The MC3090Z was designed with retail in mind, with retail RFID applications. And there were a couple of key factors that really drove the design of the 3090. The first is ergonomic
Trying to
performance.
find the
In
shortest.
typical retail applications, the user may be using the 3090 for anywhere from 60 minutes to 90 minutes continuously. So you have to have a product that's ergonomically superior, that's lightweight, that somebody can use continually, day in and day out, without affecting their productivity in other ways. So the 3090, number one priority, extremely good ergonomics. It's also important for retail RFID applications that the RFID reader be able to acquire a large number of tags in a very short period of time. And that's because in a typical RFID application, you're trying to acquire all of the RFID tags that are in the store. That's a large number of tags. So the 3090 was built with a very particular antenna structure that's designed for high-speed, high-quantity RFID tag acquisition.
Okay, that was really the main point that I wanted to make. Question?
I assume those that in the video were passive,
Yes.
and I assume they were all the same frequency.
Yes.
You can't see that they're, each tag goes with different frequencies, so
Right.
how are they discriminating,
So
when
there's-
all the tags start talking to each other?
Yeah, you have to look at, there's a kind of a protocol layer, basically it does sort of this, it's kind of like a UDP broadcast, it's an act. And then everybody starts responding, and every time the reader hears one of them, it tells that device to stop talking until it acts again. So then it'll run through and listen and grab all of them, and then it's a really fast process, but it's actually operating up here in the ultra high frequency range, the 900 megahertz range here. So this is where you see, the 900 megahertz is where you start to see that kind of an application, high tech.
Yeah, so they all have unique IDs, right? So is it just recording which unique IDs are from that?
Yeah, actually typically in the protocol, that's how in the act process, they're
So you would respond at 3 times over the map, right?
right, but it's just noise, so in the protocol, they can say,
You should actually tell what they will turn on.
yeah. Stop talking until I broadcast another app. So up here in the high frequency, or down here in the high frequency, in the 1356, this is where NFC lives. NFC's 1356. Now it says up here that it's 1 to 3 foot range, up to 3 foot range. Yeah, theoretically. But any of the phones that you have are going to be 1 to 4 centimeters in practical read range, and you can get into why that is.
You couldn't get distance.
Sorry?
If you couldn't write an application where you put tags on your keys and you could find your keys with one, because it doesn't have the range.
No, and the intent, the beauty of NFC and the purpose behind it is that it represents intent. It represents that I actually am trying to talk to something. This is my physical world equivalent of clicking on something. I don't want to read something from distance. I'm trying to show that I have an action here and I'm looking for a response. And so that it's very much on purpose that it's short range.
So what was